Okay, in this video we'll look at derivatives of some exponential functions. But first, in this upper right, I wanted to point out, what does that mean? Well, we know how to do the derivative of a monomial or even polynomial, right, where we have the variable as the base and the numbers as the exponent, right? The rule says we bring the exponent down and then we subtract 1, so 2x to the 1, right? That's review. But 2 to the x, notice now the variable is in the exponent and the base is a constant. The base is the number. So one would think, all right, bring the x down, 2, and then subtract 1, so I guess x minus 1 for the exponent, but that's not true. Okay, that is incorrect. These are exponentials and they have a special rule. There are different ways to show it and explain it, and I think this is the most basic. We won't look at why in this video. Instead, just look at the rule. So any time we have a base, whoops, oh, that's all right. I don't see my undo button. Oh, there it is. Anytime we have the base and the variable has the exponent like this, the rule is that it stays the same, but we multiply by the natural log of whatever the base is. So ln 2 multiplied by 2 to the x. Okay, the 2 to the x stays, and we multiply by the natural log of the base. E to the x is a special case. It's the easiest derivative you're going to see. It's e to the x. It remains unchanged. Now really quick, why? Well, if we wrote ln e like I had said for the second one, the rule, right? Ln e is 1. Natural log and e are inverses, right? So that's 1, so multiply by e to the x. 1 times e to the x is e to the x. Okay. That's what we're looking at. Most examples you will come across involve the last one, the e to the x. But if you do get a base other than e, still pretty simple. You keep it the same and multiply by the natural log of that base. I'm jumping straight into some more complex problems. We don't need to do derivative of e to the x 100 times. So let's look at these following 3. Okay. First one, it requires product rule. We have x multiplied by e to the x. Neither is a constant, right? We have e to the x, which contains a variable. We have x that contains a variable. So we need product rule. So f is x, f prime is 1, g is e to the x, g prime is e to the x. So the derivative, either write dy dx or y prime, same thing, derivative, is f prime g, so f prime g 1 times e to the x plus f g prime, x e to the x. Okay. Many of these, it's a good habit, this answer's fine, don't get me wrong, but it's a good habit to start to factor, because say I had asked when is the derivative equal to 0, right? When is there a horizontal tangent line? Well, to solve this, we'd need to set it equal to 0, and hence we'd need to factor out this e to the x anyways. So either answer is fine now, but this, if we're doing anything else with this function, you're gonna end up needing to factor it anyways. Okay. The next one's a bit more complex. We still have product rule. Here's f, here's g, but g contains chain rule. Okay, multiple steps in one. So let's write it out. F is 8e to the x. F prime is 8e to the x. G is the whole rest of that, 1 plus 2 e to the x squared. Now we could, in fact, distribute this out. It's only a squared. Right? We could distribute that and then multiply the 80 to the x in after you FOIL the binomial. I don't know, seems too much work to me. I don't really want to expand that in, especially, you know, what if this were 8 to the 8th power? Then no thank you. So let's just do it this way. So chain rule says bring the 2 down, 1 plus 2e to the x squared, not squared, subtract 1. Right, bring the 2 down, and then chain rule says multiply by the derivative of the inside. Well, derivative of 1 is 0, and 2e to the x is 2e to the x. So that last part is the chain rule part. I don't want to crowd this one, so let's go ahead and just write it below. So y prime, the derivative, is f prime g. Let's switch colors to f prime g. 8e to the x, 1 plus 2e to the x squared, plus fg prime, 8e to the x, times, let's see, we could combine these two, I guess, 4e to the x, times 1 plus 2e to the x. Now that's pretty ugly. Factoring will clean it up some, but some of these, you know, they're just going to be kind of ugly answers. For instance, I see both of them have this 8e to the x, right? Both terms. So let's factor that 8e to the x out. Both terms have this 1 plus 2e to the x. It's just this one has a squared, this one only has 1. So we'll factor that out. And that is about it. So I'm going to go ahead and do brackets. What we have left on this first term is still this 1 plus 2e to the x. What we have left in the second term, right? So by second term I mean that. The first term was this. We have just this 4e to the x. So combining like terms, we have this and this is 6e to the x, so 1 plus 6e to the x, 1 plus 2e to the x, 8e to the x. Okay, this is all factored, and if we had to set it equal to 0, right, then this answer does look a bit better than this answer here. All right, last example here. So I want to do one with quotient rule, right? Nothing spectacular, but quotient rule, f is in the numerator, g is in the denominator, so f is e to the x, f prime, e to the x, g, x plus 1, g prime, 1. So the derivative, y prime, is f prime g, e to the x, multiplied by x plus 1, subtract fg prime, so I'm going to draw it over here, fg prime, e to the x times 1, over g squared. All right. Cleaning this up a little bit, all we can do is factor out this e to the x here. And what are we left with? We're left with x plus 1 and then minus 1, right? Because we factored out that e to the x. So e to the x and then 1 minus 1 is 0, so times x. And there you have it. You know, many people find this section actually the easiest. Once you know product rule and quotient rule and chain rule, you know, once you're comfortable with the basic derivative operations, derivative of e to the x is the simplest function to differentiate.